Thank you for joining us today for our webinar, Pitfalls of AI in Procurement Processes. I'm Harshita, and I'll be moderating the session today. With me, I have Pradeep Sriganesh, CEO of Veriscape, and I'll pass it to Pradeep to briefly introduce Veriscape and give you a little bit of brief background about himself. Yeah, over to you, Pradeep.
All right, thanks, Harshita. Um, thank you again, Harshita. So thanks for joining the webinar. One of the things I wanted to mention off the bat, like we do a bunch of these webinars, and the reasons we do it is, we've been in this space for 25 years, and working in procurement with customers, vendors, and we've learned a few lessons. And the other is, like, we go around to a lot of trade shows and conferences, and the question that's been coming up, last 2 years a lot is, how can I use AI? Where can I use AI? What can I expect from it? And that's kind of what I wanted to delve into today, to kind of like what the state is currently, how it ties into procurement, and the next steps forward. But before I jump into it, I just want to give an overview of Veriscape and myself. So Veriscape was founded in 1999. It was actually a bunch of software developers, and the initial, they weren't going to go into procurement. They kind of fell into it, kind of like a lot of us. So they were at a site in Engelhart, which is a paint manufacturer, and they were showing some sort of self-modifying code, which is a high-tech thing at the time. And instead, Engelhart went, no. The biggest problem we have right now is catalogs. Finding catalogs, getting catalogs online, that. And they were like, oh, that's a problem we can solve. And so that's how our product IntelliCat came out, and that's also how we kind of entered this procurement space. Myself, I've been in the CEO role now for close to 2 years. My background's actually in theoretical physics, and then, through finance, I ended up in procurement now. But having my background in theoretical physics, which is, a technical subject with heavy foundations in mathematics, the whole thing with AI is, has caught my eye. And some of the methods they've used have been around for a while, but it gives me an insight into perhaps how it could fit into procurement, since I have my foot in both spaces, and also like the shortfalls that come about from it. So what are we going to talk about today? So first, I just kind of want to go over large language models. And so when people discuss AI, especially these days, we're talking about ChatGPT, Bard, Copilot, and some of you might look at GitHub AI or something like that, but they've all got one of these underlying technologies, which are all based on large language models. I'm just going to go a brief overview of what they are. And the reason for that is then I could kind of explain why there's these pitfalls that occur, or what to look out for with AI. And then, not to make it all a doom and gloom session, and talk about where I've seen it kind of used successfully, or where, people have approached it in a way of like, what can I use to solve my current workload or problems? And that's, some, I'd call it AI successes in procurement. Not that I have a crystal ball, but understanding the underlying maths and some of the technical limitations, I can make a somewhat guess of, what the future of AI and LLMs, large language models, is going to look like, specifically for those large language models. And that's probably in the near future, unless there's a huge breakthrough, what we, are focused on. And then finally, of course, I know there's been some questions that have come in, and we'll leave some time to answer some of those questions. All right. So when I was working on this slide, and I, talk to my team about it, and they were like, whoa, 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 no, don't mention statistics, because everyone's eyes are going to glaze over and they're just going to fall asleep. And I was like, all right, so just bear with me for the next minute or two. I'll keep it brief on the statistics front so you could just stay awake. I want to take the large language model and shrink it down to something that you've all used and have seen for quite some time, and that's predictive text. So when you type hello, how, you will get a bunch of suggestions. Now, the way this works is, you type hello, how, the model is looking at like, what's, first, is this probably going to be a question or a statement? And then from there, it says like, what's the most next likely word? And it might say R. And then it says, okay, now if I've got hello, how, and R, what's the most next likely thing? And it's you. And then it builds up kind of this probability tree that is essentially, statistical in nature. And so if we look behind at the machinery, we'd see that hello, how are you has a 50% suggestion, and how is it going is like a little lower, and at the very bottom is how is your cat, which is very low, and it might not be suggested at all. So it's ordered in a way where you see what the most likely is going to be suggested to you. And this is important because it comes back to how AI models are trained and the answers you get back from it, be it in procurement or just in general business sense, is how you should look at that answer and how you should weigh its response. So predictive text, it's not trained on that much data. It's very new. So the big breakthrough was GPT-3, and I think we're on 4 now. And that was the ability to take, they took 570 gigabytes of text data and were able to put it onto a neural net. And the bottom right there is kind of a simple, 2D representation of what a neural net might look like, if you just imagine it in your head. And that translates, by the way, that 570 gigabytes roughly translates to about 57 million books. So, what does that kind of mean? And so I'm going to borrow a little from pattern recognition to explain a little about the neural net, because this ties into how the AI models are trained. So if we have that net in the bottom and it's completely blank, it has like dots and lines. And what you're looking to do is weight those lines to get a certain result. So you show it a picture and go, this is a cat. So certain parts of the network get encoded and they get certain weightings. And you go, this is another cat. And that gets reinforced. And then you say, this is a dog. Another part of that gets reinforced. And then when you pop up a picture and say, of a cat and you go, what is this? A part of that network's going to light up and you're going to go, it's a cat. But if you look closely, you'll see part of the network light up and little parts elsewhere light up. So this is where it's statistical and probabilistic in nature, where it's like, it's kind of 95% sure it's a cat. So it gives you cat. And if you showed it a lion, which it has not been trained on, it'll give you an answer in total confidence. It might say a cat. Hopefully it says a cat. But it might be like a 65% confidence. But you're never shown that number. And one of the reasons you're not shown that number is, as competitors, let's say Bard and ChatGPT or OpenAI, if they could peer behind and see what the statistical weighting is for certain things, they can kind of peer into the background of the model. So they don't show you those actual values. And all you see is like, it's a cat. And you're like, oh, it's a cat, great. But it's actually, there's a weighting to that, whether it's right or not. The other part is this data is old. That's why they made GPT-4. GPT-3 was on old data. I think it was pre-2021. And so anything more recent or any new ideas or context, it's not going to understand. So it's something, again, you have to train, the AI as you go forward. So if you think of it in a business sense, you have a company, you've bought a model from a vendor. After a year, you're going to have to update it with either your latest processes, latest historical data, to keep it up to date. And that can vary from cheap, depending how it's retrained, to very expensive, depending what quality you want. So another pitfall that comes through, like I said, GPT had 57 million books in essence, but you're giving it historical data. So it's going to pick up all those nuances. And sometimes you won't know till the end how that works. So these are two cases which I think were very interesting. So Amazon, they had a much simpler large language model. And what they did was they took all their hiring data, they fed into this model and used it as a precursor to go to someone. So it would be like, it'd look at resumes or CVs and say, oh, hey, yeah, this one's good, this one's not. And what they found was there was a bias. And what it turned out was the model was, pushing up male applicants over female applicants. And so they looked back at the historical data, and true enough, Amazon had a tendency to hire men over women. And that's reflected because it was trained on that data. The Apple Card was a more recent incident, and I think it ended up in a lawsuit which was settled out of court. They created a model that worked off, financial data was fed into it. And a smart individual fed it two identical financial data sets, same assets, income, all that. And one of the sets always got a higher credit score. The differentiating factor was just male and female. And looking back at the company that gave the data, they went back and looked at their processes, and there was a bias to give men a higher credit rating. So that's, again, something that's going to be, picked up. So if you kind of think forward, thought experiment, you're training your model to help you with your procurement process, maybe look at proposals, supplier renegotiations or whatnot. If your company has a favoritism or, towards a supplier, that's going to be reflected in the model. So what you might be expecting this to be an unbiased report on, say, a proposal. But if it has a certain supplier, it might be a little more favorable. And to figure out if that bias is inherent, it's working with the vendor who can query the model with the right types of prompts. So in a way, they're kind of looking at the network, seeing what lights up and why other certain areas not lighting up or lighting up. And so that's where you kind of have to, in a way, I don't want to say data cleansing, but it's kind of sort of normalizing your data to try and remove some of that bias. So context, now this is an interesting one because this is more of a technical issue. And I think as we go on this year, next year, it's slowly going to get solved. But it's something that does come up and should keep in the back of your mind. So even in ChatGPT's own documentation, it warns about what happens if a conversation goes too long. So let's take a step back and let me tell you what context is. So when you start a question or saying like, I want to learn about X, Y, Z, can you please give me a summary? You'll get a whole bunch of things. And then you're saying like, I'd like, you dig deeper and deeper. Context is like a memory, and it kind of scrolls across your question, the responses, but it can only be so big. So eventually your question is going to come out of context, like it won't remember. There's ways to tell the model like, hey, please remember this. It's important for the upcoming conversation. No, please, you just say, remember this, but you'd have to kind of prompt it to do that. But once it goes out of context, you might find that the responses tend to be cyclic, like you're getting the same thing over and over again. And this is something common in large language models where you just get this repetition that keeps happening. So, and that's just a technical thing. And I think as we get better and understand, the software gets better, we can make the context larger and larger. So currently we can make it large, but what happens is it takes a long time for the model to reply because you're adding a whole lot of extra tokens or languages, language tokens back into the model, and it's trying to decipher it. So I briefly mentioned training and the costs. So if we, you're all probably aware or not aware that NVIDIA has made a lot of money selling their chips, which run AI and can train AI. So this is the hardware costs associated with it. Then there's also the expertise of feeding in new data, which again has to be cleansed in some fashion or normalized. And then something which I haven't mentioned is the licensing pitfalls. So you're giving your data to a model. It gets put onto a neural network. There's no way to say like, hey, that's my data, I want it back. And it's unclear right now who exactly owns that intellectual property, because it is intellectual property, because you've fed your data, which is unique, and you've created something unique on someone else's platform. It's not as simple as, if I was to say we exist on like Azure cloud, we have a data warehouse there. If we want it back, we go, this is our data, we're taking it off. That's it. But this is not so easy when you come to these large language models. And the other issue we've come across, in conferences and stories we've heard as well for ourselves, is people tend to equate, because the answer comes back, this is a cat. They take it as, oh yeah, that's done. And a colleague of mine, had a really good insight. He says, these models are trained on text, not numerical values, not data analysis. So don't expect them to do data analysis. You might get an answer, but it may not be correct. And the biggest flag should be, if you feed it data again, rephrasing the question for some numerical objective you're trying to do, some analysis, you'll get slightly different answer. And that kind of goes back to that whole thing of it's not going to be reproducible. And anyone who's well-versed in data and analytics, that should be an immediate red flag. It's like, oh, I can't reproduce these results again. And that's true if you retrain the model, you may get slightly different results, and you won't know exactly why. There's a company, Databricks, who have married, I believe it's Dolly large language model, with data analysis. And what happens is you feed it, in the front end, and it does an initial interpretation. It says, oh, this is related to data analytics. And so then it hands it off to its own machine learning module, which is geared towards data analytics, and then it runs that. So there's a little bit of trade-off here. So, one's to handle, chat, natural language processing, and then we move on to analytics. So which leads into what are some of the, so there's all the doom and gloom out of the way. Now, what can we use it for? So a really good use case that I've seen and would help me a lot is I do use Ariba from time to time. Unfortunately, it's very infrequent. And every time I go into it, I get lost in all the menus. Like, where do I go? How do I find the order screen? Am I in the right order screen? And so I've seen this demoed where they have person just says, I need to update order XYZ with this status. And then if it's not able to do it, it brings up the right context of go here, 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 here. So you could say it's a chatbot in steroids, but if it has the process in the background to know how to do what you've asked, it'll do it automatically. And going back to the chatbot on steroids, ourselves, we've played around with it here at Veriscape, and we can say like, which cost center is associated with certain PRs or something like that, or how many blah, something like that, which it knows then to go get certain requisitions of something and then run a query, which is again tying that data analytics back. So that's a bit more like chatbot and steroids, but it still is a big leap forward. Another one which is very useful that we use internally, and we use Copilot in, in the Azure platform, Microsoft, is if we have a negotiation coming up again, in the calendar, Copilot groups together a whole bunch of emails, or if it was a meeting from last year, groups that, it finds it, kind of gives a summary. So if there's new people, I can just kind of send that block off. And I kind of call it like the little project manager on my shoulder. And, that just cuts down a lot of time, cuts down a lot of management. Like, I need to put this in this SharePoint tied to this supplier. Like I find, Copilot's very good at doing this for us. Took a little bit of setup, but, we managed to get it going. Another one which looks at procurement processes, which I think is really unique, is Fair Market. And what they do is they understand your procurement process. They code their AI to kind of look at that process, and it just follows you along as you use it. And the case study they had was, for tracking tail spend. So sometimes for these very small amounts, people just do it on the fly and there's no reporting for it. And then Fair Market, their tool, it kind of flags it, says, hey, here's some Maverick spend, here's how you can tackle it. It gives you suggestions, but more to the point, it does it on the fly and you're able to see it and act on it rather than look back 3 months and try to reconcile things. Another great use case is contract management. So in some caveats on this, you need some sort of standard contract template. And from this, the AI system can extract dates, payment terms, and things like that. And even if you know what the, if it recognizes a supplier, because from your database, you can also start to categorize the supplier, update the records that need to be updated. So that sort of little tactical stuff it can handle, kind of freeing up someone to be working on the strategic side of things. But the caveat here is that it kind of has to have that standardized contract template. So, if it's one of those unique contracts or one-off contracts, you'll still get an answer, but you need to be careful and you may just need to go over it just to make sure that it got everything right, because it may not be correct. All right. So like I said, I don't have a crystal ball, but understanding the maths behind the large language models and the technology and the software used, I can guesstimate some of the things. I think the biggest thing to look for is specialized language models. So this is like for the industry. So there's a big push right now to make a large language model for healthcare. Of course, the issues of bias and data rights are still being sorted out, but I think that's going to be, the big step. So it's training these for specific purpose. So we take a step back, Bard, Copilot, ChatGPT being trained on this enormous data set that's very general. So you can answer general questions, but once you start to get specific, and I think if you ask anyone who's an expert in their field to talk to, to interact with one of these clients about their specific expertise, they will be like, no, it's getting this wrong. It's not doing this right. It's giving me the wrong answer. You'll hear that a lot. So it's good at general things. It's good at pointing at things. It's good at summarizing stuff. But once you're getting into specifics, you'll need a specialized language model, specialized AI. The improved contextual understanding, or in terms of the memory it can keep, and this will be more useful for, as your company is running, because you don't want to like pause, like take a year's data and scrunch it up and then feed it into the model again. You want this deltas to be much smaller. And I think that's something that's just going to come with time that will be easier to do. But again, that's still on the horizon. No one's licked that problem quite yet. Then the other two are more, sort of people problems is how do we handle bias in these data sets? What should I look for? And I think, if you're in the role as a procurement person, you will be aware of certain rights, but again, it's about pulling people in from other areas, especially if you're thinking of rolling this out, in terms of a purchasing system. And then data rights I've briefly discussed in licensing. You're going to have to talk to the vendor, discuss what can be done. And if you've got GPDR requirements, is like, how do I anonymize this data going into a model? And then the results I get back, how do I make sure that it's consistent? Because in terms of some of that cleansing, you're cutting off parts of data and hoping to get the right answer. So before we finish off, I just wanted to say like quickly some of the things we use AI for in Veriscape. Like going back to the project manager on my shoulder, and I got this tip from an AI researcher, is every day, open the phone, hit record to whatever client you use and just say, today in my day, I want to do this, X, Y, Z, discuss this in the meeting with blah, and so on like that. And then at the end of the day, go, this is what I've done. And then at the end of the week, and I keep this in one window, in ChatGPT, you'll see as one like bar, I think. I keep that conversation all in there. And at the end of it, I say, looking back at all the conversations, give me a summary and what were my blockers. And that's, it took me a little while, but I saw certain patterns emerge of like, oh, this issue always keeps coming up this week. And so, things like that. We also use it in our team environment, development team. It takes meeting notes, does action items. It's amazingly good at that. And after also at the end of the week, we can look back and see like, oh, these are the blockers that happen in the team and they keep coming up. And at the time, if you're just doing it run of the mill meetings, you kind of forget it. But when it's pointed out, you're like, oh, we need to address this. And then it starts to, my mind, I find like it's pushing us out of the tactical into the more strategic. And in terms of a research assistant, so just some quick things in when you do prompt an AI, like don't use negation. It's not very good at handling negation. So don't, say, don't give me answers about blah, but rather reinforce answers. Say like, I'm looking for an answer that talks about this. The best way I've found, and Ashton, who wrote the ChatGPT prompt guide for procurement, which is pretty well regarded from the feedback we've gotten, is you have to give it the right context. So you have to say, I am a manager at plant which manufactures this, and these are the KPIs I've designed to tackle problem XYZ. And rather than say, what do you think? You say, give me 3 questions that are going to challenge me about the assumptions I've made. And then it'll spit out some questions, and then you can think back and be like, okay, it's like someone, research assistant, I'm saying like, what's wrong with my ideas? And then it'll give back questions and you just think in the back of your mind and it'll help you kind of refine it. Because if you just go in and say, what are some good KPIs to do, manager in a plant in a manufacturing facility, and I did this like 2 days ago just to see how different it is. It gave me cut costs, supplier lead time, and I forget the third one. And I dug into the cut costs. I go, why cut costs? And he goes, it'll make you more efficient and you'll save you money. And I was like, well, I don't think efficiency and cut costs are the same things. But you could see how it's starting to go off on its own tangent. And unless I know enough about the subject matter, I'd have to pull it back in. So I think phrasing it in like, I own this, these are what I'm trying to do, and give me questions to challenge me is kind of a really good approach right now. All right, so so I'll open it up for some questions. I took longer than I thought. But feel free to reach out to myself or any members of the team or any of our resources on our website. I don't mind having a chat about this stuff. Also, if you're in Sydney or happen to be in Sydney, I always use an excuse for a coffee. I'll be glad to catch up and hang out and, chat about AI stuff. So I'll let Harshita drill me with the questions.
Yeah, we do have one with a little over time, but thanks, Pradeep. We'll just take one question at the moment. So, what benefits can we achieve from integrating AI during a contract execution period? And how do we ensure the best outcome?
So it depends what phase you're talking about. So if it's like you've already got the proposals or you're negotiating a contract, again, this goes back to if you have a standardized contract template. But I think it's more useful as to sit back and kind of summarize where we should be, where the process should be. And I think especially for something that's very people oriented, like for AI to stick its beak in and give an overwhelming answer is a little far-fetched at this point.
I have one more question that's just come up in the chat. So you
Yep.
mentioned that AI wasn't great for data analysis. A key scenario for my team that requires data analysis is around supplier management. We collect performance and risk data from our key suppliers on an annual basis. That is approximately 300 questionnaires get completed, right? Then it's my team's role to review this data and look for opportunities to drive better supplier relationship and value out of our engagement. With
Yeah.
training, could AI help with this manual process?
Yes, definitely. Definitely. That's like a really good use case. You just have to find kind of the right vendor. So especially if you know the type of questionnaires you're having and the types of results you've gotten, it might not necessarily be a large language model, but definitely if you look in that machine learning space, Databricks, Hoplites, those guys, they're very good at building that package out. Or, you could even ask us and we can look into it for you. But so that's the really good scenario of like you've got a very fixed goal, you know what you're looking for, and you can also look at your past data and kind of get an insight of like, okay, these are the right types of things we want to feed into the model. And then you just need to engage with someone who understands enough of the model to make sure that so what happens is when you have that many questions, like question 1 might be slightly related to question 11 and then slightly related to question 17. And so you need someone to say like, there are some slight correlations here between these questions. And so the weighting for that category that goes into the model should be weighted together. So things like that, you'll need to talk to the vendor and sort of get that grouping, just so you get the right outcome. Because if you weight them differently, especially if they're related, you start to get some nonsensical answers because you're treating two variables which are actually dependent as independent. Anyway, it gets tricky, but I love that kind of stuff. It's really interesting, and it's like I think it's a fun problem. Anyway, I know we've gone over time.
Well, thank you everyone for joining us. We will be sending the slides and the recording next week. And if you have any questions or would like to connect with our team, please feel free to reach out to us via our website or via LinkedIn. And have a great rest of the day. Thank you.
Thanks, everyone.